In the last video, we started to look at the unit circle or cast diagram. When it comes to solving trig equations, we can use a range of different techniques to find the solutions. In this video, we're going to look at some of the techniques that we could use and the advantages and disadvantages of each. The trig equations that we'll look at in this particular video are not going to be the most challenging ones, as there's a full unit on a range of different equations that we'll need to solve. So let's look at different ways that we could solve some basic equations. Let's say we have now sine x is equal to 1/2 and we have x in the interval. So we say that x is in the interval from 0 degrees to 360 degrees. So what we want now are the solutions. If you can recognise this as one of our special angles, we can go ahead and write a principal value. The principal value is the first value your calculator will give. So what we could write now, if we wanted, is the principal value for x. X is going to be equal to 30 degrees. So this is one of our known angles. We could use now the symmetry, and we could say that sine of x will be equal to the sine of 180 minus x. Therefore, the next solution is going to be x is going to be 180 minus now the 30, and that gives us 150 degrees. So we could list out our solutions in ascending order: 30 degrees and 150 degrees. So this was using now the special angles. Let's say this wasn't a half. Let's say it was 0.4. I wouldn't know that. So the first thing I do is use a calculator. So checking that I'm in degrees mode. If not, shift mode 3. We would now do shift sine. And I'm going to do 0.5, which is a half, and this is my principal value. The disadvantage of this is often pupils missed the second solution by symmetry. So if we had now a number that we didn't know, so it wasn't one of our special angles, this would be a good method to choose. What I'd like to do with this is think, well, are these the only solutions? A nice way to see this is to back it up with a quick sketch now of the sine function in the interval from 0 to 360 degrees. So we're going to come up to our maximum of 1, down to a minimum of -1, and back up to 0. We know this is 1, we know that this is going to be -1, we know this is going to be 360 degrees. If I consider now where sine x, remember this is a graph y is equal to sine x, is equal to 1/2 in this interval, I can draw this line. So if I do that, I can see now that I have two solutions. So a quick graph will help us out. Whilst we can't locate this one as such, we know on the calculator we've established that this is 30 degrees. By symmetry, and we're symmetric about this line right here, which is x is 90 degrees, we're going to have one the same distance back, and this is going to be 180 degrees minus 30 degrees, which is going to give us the 150. So that's one way of solving that equation. Now with this one, if we'd said where is sine x equal to -1/2 in the interval, let's say from 0 to 180. If I drew this line, we can see from this one here that there are going to be no solutions in the interval from 0 to 180. So if I just drop a line down, there's 180. So having some understanding of the graph can help here. There are no solutions. We have two solutions here in the interval from 0 to 360, and we could go ahead and find those. So that's using now either the known exact value, and that's because it's one of our known ones, and we know for 0, 30, 45, 60, 90, and then multiples on from there, or we could just go ahead and find what is called the principal value. The principal value gives us our first solution on the calculator. I've then used symmetry and then found the next one. Okay, we could have used now the cast diagram or unit circle, and we could have done this in two different ways. We could have said to ourselves, well, I'm going to take this purely from scratch, and again, this will work for exact values. If we couldn't think what we were doing, what we could do is just draw up a little triangle and jog our memory. We know that the sine is going to be the opposite over the hypotenuse. Well, this is going to give me part now of an equilateral triangle. This is 60, this is going to be 30, so we could say that this now is going to be 30 degrees. We know that all values in the first quadrant are positive. We know by symmetry sine is going to be positive in the second quadrant. So all we need to do is go ahead now and pitch up another 30-degree angle, and we would be 30 degrees back from 180. I personally think that's quite a tough way of doing it from scratch. Alternatively, you could locate this one here and say, well, I know that's 30 degrees. Therefore, using the unit circle, I'm going to have one back here, which will be 150 degrees. So rather than taking it purely from the trig ratio, you establish your first value as you know it's an exact value, and then go ahead from there. So let's say we have, for example, now sine x is going to be equal to 0.4. So this isn't one of our special angles. What I would do in this case is simply say inverse sine, and then we would have now 0.4. This is going to give us now our first value. So our first value, our principal value, is 23.6, correct to three significant figures. Therefore, what I do is write this one here, 23.5 dot 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 dot. Therefore, using the cast diagram, I know that this one will be 180 minus that. And when we're doing these, I always like to store that value on the calculator. So let's grab that, Shift Store A. So I can use this. So I can write that one down. I can do now 180 minus this one, and then I can add 360 to it if I want another one. So if we were looking for solutions in the interval from 0 to 720, that would be a nice one. So what I've done, I've just looked at solutions in the interval from 0 to 360. So if I consider those, I'm going to have 23.5, I'm going to have 180 minus that, and then if I wanted to go again, I would just add multiples now of 360. My first solution, by symmetry the next solution, then I go round again, add in 360, add in 360. And I think this is slightly easier than doing multiple ones of these. Or you can just use the fact, as we saw, the sine of x is equal to the sine of 360 plus x, as we have now subsequent solutions, as the sine curve cycles every 360. So nice basic equation in different ways. Now in terms of these, you can combine the methods. I like to combine them, especially if we get something slightly more challenging. When we come on to multiple angles, I prefer the cast diagram rather than trying to sketch a transformed trig equation. Okay, let's look at another one. So this time, let's look at something slightly trickier. Let's say we've got now tan x. So we'll take tan x, and we'll say that this is going to be minus 1 over root 3. Or if we rationalise it, minus root 3 over 3. We will say that x is going to be in the interval from 0 to 2 pi. When I go ahead and use my calculator to find a principal value, we're going to end up now with a negative quantity. When we come on to a later unit, we look at the inverse trig functions. For now though, what we could do, if we didn't recognise this as one of our special angles, simply plug it in. So this time we're working in radians. So I'm going to do Shift Mode 4. This gives me the answer now in radians. So we're working in radians rather than degrees. So we'll do the inverse tan, and we'll have now minus 1 over root 3, or if you like, root 3 over 3. So if I do that, I've got minus pi by 6. Now, when we think about this, we're interested in this between 0 and 2 pi. So that's given me a negative value. We know that the tan of x, so let's do the tan of x, is equal to the tan of 180 plus x. 180 is pi, so we get now pi plus x. So if I can say that x, the principal value, this is the first value the calculator gave me, was going to be minus pi by 6. Therefore, in this interval here, what we need to do is add multiples of pi. So we can say then that x will be equal to adding now pi, so we're going to add n lots of pi. Now n is just the number that we need to do before we go outside this interval. So the first one is going to be now 5 pi by 6. If I add 6 pi by 6, I'm going to get 5 pi by 6. I now need to add another one, which is going to give me 11 pi by 6. I don't think that's massively intuitive. We can work it out that way, but I think there are better ways of looking at this. If I drew the tan curve, I don't think this is going to help us massively. It will tell me the number of solutions in the interval, but it won't be as straightforward to see them. So if I draw the tan curve, what I'm going to have now is my asymptote, and that's going to be at 90 degrees or pi by 2. So if I went and did another one, let's go ahead and do another one. We will come back up, we'll come round, and then we'll come through. This point right here is going to be pi or 180 degrees. And then we're going to have the next asymptote just here. That's going to be at 270 degrees. And then we're going to end up now with the curve. And the curve will come back round and it will come up now to 360. Now what we're looking at then are two solutions in this interval. Where is it equal to minus 1 over root 3? We can see we got one here and one here. The graph doesn't help us find that value, but what it does do is tell us the number of solutions in this interval. I personally think using the cast diagram or unit circle for this one is quite nice. So what we're going to do then is consider where this is. We've got now minus 1 over root 3. So we know that this is going to be in the second and the fourth quadrant. Tan is negative here, tan is negative here, tan is positive here, and then tan is positive here. So we can see these two solutions are going to be in this quadrant and this quadrant right here. So if I just draw a little angle, minus pi by 6, so I could find my first one. So if I think this is going to be minus pi by 6, by symmetry, the other one is going to be pi on, or 180 degrees on. So all I've got to do then is find that I saw that this was going to be now minus pi by 6. And of course, if we work round, this is simply an angle now of pi by 6. So this is an angle of pi by 6, so we can have pi by 6. So all we're saying to ourselves is, well, let's start here. Well, this has got to be 5 pi by 6, as we're now pi by 6 back from pi. So all I've done is gone round, and then I'm going to come round and add another pi, and that will give me now 11 pi by 6. So I think that's a nice way of doing it. If you wanted to do it from the absolute bottom up, then you could say that now, just pitching up a little right angle triangle, well, I know that this angle x, let's go ahead and put this on, the angle x right here, we've got now the definition of tan is the opposite over the adjacent, 1 root 3, and then we're going to have 2. That is going to be now a 90. This is going to be a 60 or pi by 3, and that is going to be a pi by 6. So let's write pi by 3. I personally think it's easier to think about a principal value. If you know it, do it by rote. Remember, we have a table for these, or you can find that principal value on the calculator. Certainly, if we had now an let's say tan x will be equal to minus, let's take that to 0.4 again. So if we did this and we did now the inverse tan, we would have the inverse tan of negative 0.4. This would allow us to locate that particular solution. So we could say now on the calculator x is equal to the inverse tangent of minus 0.4, and this gives us the principal value. So what I would do with this particular case is just say, well, I've got this scenario, I know that I've got one down here, and by symmetry the other negative, and I'll straighten that up shortly, the other negative is going to be in the second quadrant as it's tan. So all I'm going to do, let's put that on here. This has given me an angle now of, let's grab that up, 0.38. So this is 0.38. This one is going to be, so all we would do is simply say, well, this value here is going to be pi minus the 0.38. And then, of course, all we do is just add it on. So that's a few different ways of looking to solve that. Don't be afraid to use different techniques. I like to use different techniques. I like to find a principal value, sometimes doing it by the exact trig values. Remember, we've got them for 0, we've got them for 30, 45, 60, 90, and then multiples of those quantities on. Or alternatively, you can use the calculator. Let's do one more. Let's look at cos theta. So we'll switch from x to theta. Let's do cos theta is going to be equal to, we'll go for minus root 3 over 2. Again, I'm using an exact value here. So this is one of our known angles. This time we will take theta and we'll go back to degrees. So we'll say that theta is going to be in the interval from 0 to 180 degrees. So what I'm going to do this time is just think slightly ahead of myself and consider what we're going to have. So if I draw now the cosine curve from 0 to 180 degrees, What I'm going to have then, at this point, this is going to come down to 90. That will be now 180. We'll come back up to 360. We're interested now in the interval from 0 to 180 degrees, which is going to be there. If I think about minus root 3 over 2, we're going to have a line, and that is going to be somewhere here, give or take. We can see that in this interval, we only have one solution. So what we've got then is this one solution here. If I think about this now, I can take the inverse. So if I take now the inverse, what I'm going to do is say that theta will be equal to the inverse cosine now of minus root 3 over 2. This will give us our principal value now for theta. So we can say that theta, if I think about this now using the cosine gives us now with the inverse a number or an angle between 0 and 180. This is going to give me 150 degrees. That's one I know. If I didn't know it, I could go ahead now and put this through a calculator. So we need to be back in degrees, shift mode 3, and I'm going to take now the inverse cosine of minus, let's put this in, minus root 3 over 2. So that's going to give me now 150 degrees. We know that the cosine of theta will be equal now to the cosine of 360 minus theta. So if we consider now, the next one is going to be just here. So by symmetry, it's going to be now 150 back from 360 to 10. So I've got my first one just here, and now the second one here. So we can say that the only valid solution in the interval is going to be 150 degrees. And we saw that from before. So you can use this, you can find your principal value on your calculator and then find subsequent solutions. By symmetry, you could think, well, I find this one, I can see quite clearly. Or we could go to the unit circle. Principal value is going to be over here, and we've got 150 degrees. If we think about now the symmetry, we want this to be negative. We know that cosine is going to be negative in the second, cosine is going to be negative in the third. So we've got positive, negative, negative, positive. All values are positive in the first quadrant, only cosine is positive in the fourth quadrant. So what we have by symmetry, if you like this approach, what we'll have then is this angle, and this angle is going to be a 30-degree angle. So we've got 30 degrees here, and we can see then that this is the 150. Then we have this angle right here, that's 30. Well, if this is 180, then this must be 30 on, 210. This must be 30 back, 150. And of course, if we were solving this now, we're solving this in the interval from 0 to 180. We can clearly see that in that interval there is only one solution. It's only when we go round now and make this from 0 to 360 that we would have two solutions. So again, we're just looking at different techniques. We're looking at using a calculator to find the principal value. We then consider now the symmetry and find subsequent solutions in the interval. You could graph it to confirm there's only one solution. You could use the unit circle. Again, different techniques. So if you wanted to do now cosine theta was equal to, let's say, minus 0.4 again, and we're interested in theta now between 0 and 180 degrees. We know that there's going to be one solution to that, so let's go ahead and look at that one. And what we'd have is a line. So let's draw a line. That's going to be about, give or take, minus 0.4. So we can see one solution. All we would do in degrees, shift cos, take the inverse cosine of negative 0.4, principal value. This is an angle between 0 and 180 degrees. So we can see that's 113.6 to one decimal place. And we could go ahead and either show that on here, or we could just write it down. Straight away, if you use this property and subtract that away, so if we do now, and I always like to store these in. I know we're only doing one value, but then I can do 360 minus a. And that's going to give me now 246. So quite clearly, that is not in the interval. If I wanted now, if I had a, and then I added 360, then we've got that value. If I did the same one before, I can just go back and back. So that's what we've got. We've got an angle just here, and we can see that there's only one solution. So you can be flexible. You can work purely off rote learning for exact values and then use your calculator, or you can use a range of different approaches. You won't be penalised for taking one method. As long as you're showing accurate, full solutions and full workings, your answer will be marked accordingly.